For example 2, what I'm going to do is draw a sketch. Once you start to get a few more variables and you're asked to do a few more things, it's going to be important that you do a sketch of the example so you can kind of visualize what's happening. Write down all your constants or whatever variables you have, and then go to your formula sheet and look for a formula that'll find what you're looking for based on what you're given. So we have a rock dropped from the top of a 250-meter cliff. How long will it take to reach the ground? So we're looking for time, and then we're looking for what is the velocity just before impact. So we're looking for final velocity, and also a direction. Since we're asking you for velocity, it is a vector. So let's do a quick sketch of what's going on here. Draw my cliff, 250 meters to the ground. So let's label that. So my displacement, 250 meters down. We have a rock that's being dropped off of that cliff. Doesn't say that it starts with any initial velocity, so when it's just being dropped, our initial velocity will be 0 meters per second. It's going to be traveling downwards. Since this is happening on the surface of the Earth, we also know that our acceleration due to gravity, 9.81 meters per second squared downwards. We're being asked for time, how long, so time is an unknown, and we're also being asked for velocity just before impact, so we're looking for VF as well. Now, one of the things that I tend to do is, if I calculate an answer, I try to avoid using a calculated answer to do the second part of the question, because if I make a mistake on my first calculation, I will carry that mistake into my next calculation. So where possible, after I calculate time, sometimes I may have to use it. I don't have a choice. But if I could go back and use a different formula with all the given information to find my final velocity, I will. And there's actually a couple ways that you could do this question. I'm going to show you one of the ways. I look at, to calculate time, this is the formula that comes to my head right away off my data sheet. Since we're dealing with kinematics, distance equals initial velocity times time plus 1/2 times the acceleration times time squared. Now the nice thing is, when the initial velocity is 0, that means this whole term is 0. So this can simplify to your distance equal to 1/2 a t squared. And we can manipulate this formula for time. What we need to do is clear the fraction. So you multiply by 2. So it becomes 2 times your distance. I'll show you this in a couple steps, and then we'll start to simplify these faster. Equals at squared divided by the acceleration equal to t squared. And then to solve for t, we take the square root of that whole thing. So the time is going to be 2 times the distance divided by the acceleration, take the square root. Let's put our numbers in. 2 times 250 meters divided by 9.81 meters per second squared. We're going to take the square root of that. So we'll end up with time units, right? The meters and meters per second will divide out, leaving us with seconds squared. Once you take the square root of that, you should get, punching this in on my calculator right now, take the square root of that answer, 7.2 1, 3, 9, and we have to look at the number of significant digits. Since there's 3 significant digits in this question, we write this as 7.14 seconds. I'm going to do the velocity over here on the left, so you can have all this on one single slide. I'm going to use a different formula. I could use one that uses time, but I'm not 100% confident that the time is correct. So if I put a wrong answer into my next question, I will get another wrong answer. So I'm going to use a different formula, and the one that comes up for this one, to find final velocity, Vf squared equals Vi squared plus 2AD. I have acceleration, distance, I know initial velocity. Again, this formula becomes a lot simpler because the initial velocity is 0. I end up with Vf, and I'm just going to do this in one step, being the square root of 2AD. Put your numbers in. 2 times 9.81 times 250. Take the square root. Your final velocity equals 70.0 meters per second. And we should be stating direction here. It is a vector, so it's downward. Time is not a vector, so I don't have to state a direction with time. It's a scalar, so we only state magnitude. But velocities, accelerations, displacements are vectors. They need direction.